Hi, welcome back to LeetCode. Today we discuss LeetCode problem 962 maximum with ramp. So for this problem, what is my actually content? Content is this problem statement. First I will explain the problem statement, then I will explain some example, then I will share the brute force approach. And this actually gives us the daily, so that's why we have to think about the optimal approach. Here actually optimal approach I have actually used stack. Okay. So first of all, what is the problem statement? Problem statement that a ramp in an integer array nums is a pair I comma j for which I less than j and nums I less than equal to nums j. The width of such a ramp is j minus I. Given an integer nums, return the maximum width of a ramp in nums. If there is no ramp in nums, return 0. Okay. So first of all, what is the condition? Condition is first of all position is for a pair position is condition is I less than j, and whatever the value at position at nums I, that is nums I less than equal to nums j. Okay. Now the width of this pair will be j minus I, and we have to find out the maximum. Answer will be maximum width. Correct. This is the actually condition. Now what is actually the example? Example is 6 0 8 2 1 5. So if I take the for a pair, I have taken this is our left value for the pair. Now what is the possible? First of all, what we can only take what is the value present at the right side, correct? And then I will check what is the actually value greater than 6, greater than equals to the value at the left value. Okay, so whenever we have taken this 6 as a left value, so what is the possible range? You can take this is the range 0 to 5, this 0 to 5. Now I'll check 0. Can I make a pair with 0 with 6? No, because 0 is less than 6. 8, yes, we can make a pair 8 because 8 is greater than equals to 6. Now so what will be width will be this is 0 1 2 3 4 5. So the position is 2 minus 0, it will be actually 2. Now next is 2. No, 6 to 6 comma 2 is not a valid pair because 2 is less than 6. Similarly for 1 and similarly for 5. Now whenever we placed 0 as the left value, then what is the possible range? This is the possible range, correct? Now this is the possible range. So which is a possible pair actually valid pair? 0 comma 8. Yes, 8 greater than equals to 0. So what is the width of this? 2 minus 1, it will be 1. Similarly for 0 comma 2, then 0 comma 1, then 0 comma 5, correct? Now 2 comma 1 position is 3 minus 1, it is 2. Then this is 4 minus 1, it is 3. And this is 5 minus 1, it is 4. Okay. Now we are fixing whenever can we make any pair with starting with 8? No, because in the right side of 8 there is no number which is greater than equals to 8, right? Similarly for 2, yes, with 2 I can make a pair with 5. So what is the width of this? 5 position is 5, for position of 2 is 3, so it will be 2. Similarly for 1 I can make pair with 5. So 5 minus 4, it is 1, correct? So this is all possible valid pair. So we have to find the maximum width. So this is 2, this is 1, this is 2, this is 3, this is 4, and this is 2, and this is 1. So what is the maximum value out of between all of this? Maximum value is 4. So our answer will be 4. So that's why you can check that our answer is 4, correct? Our answer is 4. So these two things are clear. First of all, I have explained the problem statement, then I explained some example. Okay, now go to the actually brute force approach. What is the brute force approach to solve this problem? Brute force approach. So we have to make all the pair. So first of all, I will take a pointer that actually point to the left value. Like here actually first of all I am pointing a 6, then 0, then 8 in this way. Okay, this is fixing the left value. Then for the right side range, I will check is there any value number that actually that is actually greater than equals to the left value, whatever actually pointing. If it is valid, it is greater than equals to the left value, then I will, this is valid pair, I will check what is the length or width of this. I will actually modify this with the, if it is greater than the answer variable, I will actually modify this. So I will take a initially our answer variable will be 0, so I will take a left value, left pointer, that is I is equal to 0, I less than n, I plus plus, and similarly for I, j is equal to I plus 1, because the range will be whatever the left pointer, and the next number of this pair will be always on the right side. They mentioned that j always greater than I less than j. Similarly for j greater than I, reverse is also possible. So j less than n, j plus plus. Okay. Now we'll check if whatever the nums present at j, if that is greater than equals to nums I, that is our one possible answer. So I will actually modify this with the answer. So what is the maximum value I have seen answer and the current width of the current pair, j minus I. Got it? So I'll modify this with the answer. Okay, so what is the time velocity of this? Time complexity. So this is a one for loop, the range is n, so time velocity will be big of n. Similarly for here also nested for loop, here range is also n, so time velocity will be big of n. So overall time velocity will be big of n square. So this actually gives a TLA, because our n range is suppose 10 to the power 4. Yes, 10 to the power 4. So 10 to the power 4, 10 to the power 4, if it is, then the n square will be 10 to the power 8 into 25, because this is actually suppose 5 into 10 to the power 4. Yes, 5 into 10 to the power 4. So it will be 5 into 5, so 25. Got it? Which is actually greater than 10 to the power 8. That's why this will give us a TLA, right? So now what is actually optimal approach by using stack? Let's see some observation, then intuition, then actually I will go to the actual code. So suppose our problem is 2 1 sorry, suppose the example is 2 3 1 4, 2 3 1 4. Okay, so with this 4, which actually the potential starting point, 1 can be one potential starting point, 3 can be potential starting point, 2 can be potential starting point. So if I can make a pair with 2 comma 4, then should I check with 3 comma 4? No. Why? Because I have already have a pair that is actually width also greater than, like whatever the width of this 2 comma 4, width of this will be, width of this is 0 1 2 3, 3 minus 0, it will be 3. Okay, and for 3 comma 4, width is actually 3 minus 1, it is 2. Okay, so if I have seen any smaller element that actually present on the left side or at the front, that will give us the more effective or it will affect more actually in our answer, because this will can be give us the length is actually maximum, right? So that's why I will, whenever we have seen any, so we are iterating our input array. Okay, so first of all is seen 2. Okay, then I'll check the next. Okay, I will store this. This is first time, so I will store this. What is the element I have seen? Now go to the 3. So should I actually store this? What is the this is actually potential starting point? No. Why? Because whatever the number can be paired with 3 comma with 3 comma x. Okay, any of the number on the right side, that will be always paired with 2 comma x also. Correct? Because 3 comma x means what? The x number should be always greater than equals to 3, and if I want to make with pair 2 comma x, then also x greater than equals to 2 also already. If x greater than 3, greater than equals to 3, then it obviously is x greater than equals to 2 also. Correct? So that's why we don't need to check with 3 comma with any potential starting point. Correct? So I'll not check with any pair with 3. Okay, so now it is 1. 1 is less than 2. Yes, this is one possible potential starting point. Why? Suppose what pair actually I can make, suppose 1 comma 3. Okay, and this is actually suppose I have seen 4 here, 4. This is suppose 4 1. 4 I have seen first, then I have seen currently 1. So whatever pair I can make with 1 comma 3, can I make with 4 comma 3? No. this is not sure, but this is sure. This is almost 100% sure that whatever pair I can make with 3 comma x, that I can always make with 2 comma x. But this is not true in the reverse case. Like whenever we see any number that is actually less than the previous or the smaller number or the number that I have seen till now, this is the current situation. Suppose I have seen 4 first, then I am seeing 1 now. Then whatever pair I can potentially pair actually 1 comma 3. But can I make pair with 4 comma 3? No. Correct. But you can check with this condition. Suppose 3 comma 4. Then can I make with 2 comma 4? Yes. Yes. Correct. Correct. This is correct. Clear. This intuition clear. How it is affecting this one. So I will just store whenever seeing any greater number that is stored in the previous. I have seen the previous. So I do not need to store that. I do not need to check any pair with that, because if I want to if I can make a pair with that value, the previous smaller number, because that will give the more width. Correct. So that's why I don't need to count the current number. Now if I see any number that is smaller than the previous number I have seen, then I have to store this, because this can actually create new pair. That actually where actually condition is nums I is less than equal to nums j. Correct. So that will be create a new pair. That will not be not be able to create with the previous number that we have seen. For this case, you can actually take this example 413. Okay. So I can make pair with 1 3, but but I can't make with 4 comma 3. So that's why we have to store this one. Okay. Now what I was storing in this by using in stack or any other data structure, that I was storing this the decreasing value of the input array. And what is the decreasing value? So it will actually, what is the value actually indicated in stack? Stack indicated that what is the potential starting point or the left value. Like for this example 2 3 1 4 2 3 1 4. So first of all stores to 2, because this is our stack is empty, so this is first value. Next is 3. I will ignore this, I will not store this, because 2 will give us the whatever the pair I can make with 3, I can also make with 2, and also give us this. So with 2 actually give us the more width, so I will not count 3. So now go to the 1. Yes, this can actually create new pair. Now 4, no, because our top value is already 1, so I don't need to check with 4. Whatever value I can make with 1 comma x, I can also make with 4 comma x also. Correct. So I don't need to check, I do not need to store also. So this our stack is look like. So what is storing the decreasing value, and it is indicating the starting value, starting pointer. Okay. Now again I will start. Okay, this I will process this. I am stored what is the maximum value. Now again I am traversing the input array from the end. Okay. So for 4, what is actually possible pair? So I will check this. Okay. Can I make a pair with 1 comma 4? Yes, I can make a pair. What is the width of this? So 0 1 2 3. So width of this will be 3 minus 2, it will be 1. Okay. So I will pop this. Okay, I will pop this. Now what is actually value stored in the stack? 2. Can I make a pair with 2 comma 4? Yes, this I can make. So what is actually width of this? 3 minus 0, it will be 3. Okay, so this is the answer. Now go to the next number. Next number is 1. Is there any number in the stack that is empty, that is not present in the stack, that is actually smaller than equals to the 1? No, it is stack. Currently our stack is empty, because I have actually popped 2 also. Now go to the 3 also. 3. Can I actually is there any number at the stack that actually less than equal to 3? No, it's only for 2. Okay, so in this, so for this example our answer is 3. You can check, this will give the maximum width 2 comma 4. So in this actually stack will help us in this way. So this type of stack actually we call actually monotonic data stack, monotonic stack, because we are actually storing data in sorted order. Sorted order means in the here actually we are storing in the decreasing order. You can store the increasing order also. Okay. Monotonic means in one direction, it will constantly up in this one. In this way also possible, or constantly down or negative. Okay. So just go to actually code. I think it is clear. If any doubt, you can comment on that. Okay. If you like the explanation and it is like the actually video also, please like the video. Okay. You can also comment if you found it useful. I have tried to explain this problem as much as easy. So let's go to the code. So here I have taken first is stack origin storing the integer data type. Now our initial result will be 0 and n is our input array size. So I am just traversing first input array A. Okay, I'll check if the stack is empty or the value that is present at the top. Okay, I am actually storing the index of that, so that's why I am checking the that particular input array, that position index. I'll check what is the current value that is actually greater than this, means 2 1 2 3 1 4. So here actually I first because this is empty, so I'll push I here. I'll store 0, I 0. Then I go to 3, means index 1. This I'll check this is not empty, and I'll go to the next condition. Next condition is A1 that is actually greater than equals to stack top is 0. Array 0 that is greater than equals to array 0, for the value is stored on the top. So this is stored as 2 and this is actually 3. No, this is false, so I will not insert this. Okay, go to the next index is 1. So I'll check what are the value at position at 0. Position is 2 is greater than equals to 1. No, so I will not actually store this. Okay, so I will just store 1 here. Sorry, the index will be 0 1 2 index. So s dot top means okay, first of all I will store 0 here because this is empty. Now I am just traversing to 3 top value is yes, top value is 2 greater than 3. No, so I will not store the index 1. Now go to the next index 2. So what is the value stored at the top value is 2, and what is the current value is 1. So that's why it is true. I will store 2 here, index 2. Now go to the next 4. So top value is currently it is 1. Top value is 1 now, and our current value is 4. It is 1 greater than 4. No, so I will not store this. So our stack contain this 0 and 2. This 2 index. You can check this is actually decreasing value 2 and 1. Now go to the next for loop. This for loop actually we are checking all the possible potential pair. So I'm starting from end, and I already know I is equal to n minus 1, I greater than the result. Okay, I minus because length I have optimized more actually, because the length actually I have already heard of the length. If it is already I have reached that, we can't actually check any other pair possible, right? So suppose in the initially we found actually our answer is 4. So do I need to check with whenever our length is actually 3? No need to check, because we have already got the maximum answer. You can also don't need to optimize this. You can actually use I greater than equals to 0 also. So while our stack is not empty, and whatever the value stored at the top, okay, that and less than equal to the current value, that's actually a valid pair, correct valid pair. So I will take this pair and I will check what is the length of this. So length of this means width of this. So width of this will be I minus what is the current index and the s dot top. So first of all I will actually check 1 with 4. So what will be length? What is the width of this? 2 minus, and index of this is 2. Sorry, 3 minus 2. It is 1. So our answer will be currently 1. Result is modified to 1, and I have popped this. So our stack is currently contain only 0. Okay. Now go to the next. Next, while is there any stack is not empty still, and what are the value position storage 2. Okay, and 2 less than equal to 4, yes. So I'll again check what is the width of this actually 0, and currently with the 0 1 2 3 minus 0 it is just 3. So our result will be 3 now. Okay, and our current stack is actually empty. Okay, now our stack is empty, so I'll break from here and I'll return the result. Result is 3. So you can check what is the answer should be 2 1 2 3 1 4. So this will be our answer. So 0 1 2 3, 3 minus 0, effectively it is 3. It is clear? It is clear, right? Logically. So here also why I am popping also, because whatever the value I actually effectively creating 2.4, this actually give the maximum length, because I have checked with 2.4. Suppose this is actually not giving the maximum length, so I will come to this now 2.1 suppose. So this can give the maximum length? No, because our length is already optimized. Optimized, we already shifted on the left side, so our length is already decreased by 1. So that's why whatever the actually maximum currently I'm seeing, this will give the maximum length, because I'm checking with the, I'm starting from the rightmost point. So this will give the maximum length, maximum width. So that's why whenever shifting, so do not need to check with this again, because it can be create a new pair, valid pair, but we don't need to count this, because this always give the width will be always smaller than the previous with this, correct? So now it is clear. Please like the video, and if you need doubt, you can comment on that. Okay, and please subscribe the channel if you're not yet subscribed, and you can share also with your friends. Now what is time also to this? Time complexity. So we are iterating the input array once, so time complexity will be big of 1. Again we are traversing this big of this for loop from the end, so time complexity again big of n. So ultimately time complexity will be big of n. Now what is the space complexity? We have taken a stack here and we are storing this, so it can go up to big of n, because it can be possible that all are actually sorted. The input array is 4 3 2 1, so we will store in the stack all these 4 position. Right, it may be a possible situation, so that is a space complexity big of n, correct? And in the description I will share the actually code. Okay, and please, if you're not yet actually clear, you can please actually see this video once more. I think it will be actually easy compared to what is the problem statement. Okay.